Hello everyone, welcome to 2018. We are doing section 4.1 today. So first up is the equation for exponential growth and decay. Let's talk about what these variables mean. So A is your starting amount. Whether you're studying how many bunnies you have or how much money you have, A would be the starting amount. B is going to be your growth factor. And then X is just your variable, so it'll be always changing, but that's normally a time period, like years or something like that. Now something I do want to note is A and B are always going to be positive numbers. So A and B will always be greater than 0. What value do you think would cause the growth versus the decay? Like if I change one of the numbers, it could perhaps cause the grow versus decay. So you think if I plop a negative out front, it would cause the decay? No? Spencer, you have a guess? What would you want to make the growth factor negative?
Only negative. You have to make it less than 1.
Right, very good. So the growth factor is your guide, and that's your B value. If B value is bigger than 1, it's going to cause the graph to grow. If B is between 0 and 1, such as like 1/2, then it's going to decay. Raise your hand if you remember doing this in Algebra 1.
Yeah.
Because you did it. You probably forgot if you didn't raise your hand. So growth, I'll just have green be my growth. Growth would look like this. And decay would look like this. But notice, my graphs are never going into quadrant 3 or 4, are they? There's actually an invisible boundary line right about here called an asymptote. Can you say that word? Asymptote. We'll write that down in a few minutes.
I just don't know how to do it without taking.
All right, let's talk domain and range. So it's been a while, but domain is where your graph can travel left and right. Does it look like these graphs can travel left and right as far as they want to? Yep. So how do we say that? All reals. So you can either write it like this, or you can write it negative infinity through infinity. Your choice, however you want to write it.
You want to.
And now I'll talk you through range. Your range is basically all positive numbers excluding 0. This graph will never touch 0 because of that asymptote. So you want to write it 0 through infinity with a parenthesis. Because a parenthesis will not include the 0. If you did a bracket, it would include 0. Yep.
How would you read the word that started with the A in green? I'm sorry.
Oh, growth. It's just my board's not lined up, so my handwriting is appearing very sloppy. I'm sorry. Okay. Growth. All right, we had a good question when I paused the video, and that was, will the green line, exponential growth, and the pink line, exponential decay, both have the same domain and range? Yes, they absolutely will. They can both go left and right wherever they want to go, and they can both only go up and down from 0 through infinity. So they can only go from 0 to infinity. Neither one ever goes below 0 or touches 0. All right, next up is the word asymptote. Go ahead and practice saying that. Asymptote. Asymptote. Don't call your dad an asymptote when he gets mad at you. Don't do that. I know, I heard that some of the teachers say asymptote like as though it was a swear word, but don't do that. So an asymptote is an invisible boundary that lines cannot cross. They can get really, really, really close, but they cannot cross. And our asymptote on all of our graphs today is going to be at y equals 0. Actually, I lied. Our asymptote will slide up and down today. A little later on. Yeah, Spencer? Was that the question? Yeah. When we take these graphs and slide them left, right, and up, down, the asymptote will slide along with the graph. Yep. Yep.
How would we space the graph off of the asymptote or asymptote off the graph?
I would base the asymptote off of the equation of the graph.
Okay. This is a new desk. I don't like it.
All right. If you have not yet, get your graphing calculators out. We're going to put a equation in the graph. We're going to look at the table, and then we're going to look at the picture and see what it looks like.
Is this an example of the last formula?
Yep. So hey, since she said that, I have a great question for you guys. In the formula, it was y equals a times b to the x, where a is the starting amount and b is the growth factor. So is that 2 right there, our starting amount or our growth factor? Nope, it's the growth factor because it's the number with the exponent of x. So all of our values will be doubling through the scenario. What would the starting amount be since I can't see it? Oh, it's a 1. There's an invisible 1 right here. So the starting amount will be 1 and the growth factor will be a 2. Let's go ahead and put it in. I got my calculator right here. Want to clear out all your old stuff from before break. Y equals 2 to the x. Make sure your x is your exponent. Next, put this in. Open your seat.
No, it's in my seat.
All right, we're going to go ahead and hit graph. Oh, my Zoom is crazy. How could I fix that problem? Zoom 6 is my best friend. Zoom 6 will be back to good. There we are. Perfect. Does it look like we have an asymptote at y equals 0, that x-axis location? Yep. And let's go ahead and fill out the table. I need to go up to -3. So 0.125. 0.25, and then every time we're just going to double. So 0.5, 1, 2, 4, and 8. Yep, and that one. All right, let's go ahead and plot a few of these points so we can connect them. Just keep in mind to not go below that x-axis because that's where your asymptote is. Perfect. And you can even draw in the asymptote if you want to be super scholarly. It's just like a dotted line. It's like a little brick wall, little concrete barrier. All right, everyone's good? No, we have a lot more to do today. That's our first graph. You really think I stand here like, we did one graph, we're done? Probably not. Mm-mm. Everybody's expecting these New Year's gifts today. They all walk in and say, no homework, right? It's New Year's. Yeah. All right. What's our starting amount and what's our growth factor on this one? Our starting amount, 1/2. And our growth factor? 4. Yeah, so 1/2 will be basically our y-intercept, our starting amount. And then everything will quadruple from there. So this will be 4 times larger, 4 times larger, 4 times larger. So I could do it that way, or I can have my calculator fill it out for me. So let's go ahead and put it in. I'm just going to type in the 1/2 as 0.5. It would be easier to type for me. And there's my equation. Where's your graphing calculator? It's dead. That's the problem with the recharge calculators. Don't keep it charged for super long.
I only had to charge mine once.
Really?
Yeah.
These calculators, their batteries stay good for like 3 years.
Yeah, but my battery one was big for the morning.
Mine too. All right, so we're looking at 0.125, 0.031, and 0.008. So I just rounded that off. And I'm going to go ahead and graph it best I can. It's still growing though, it is not decaying. And is my asymptote still there at y equals 0? What do you guys think? Yeah, it's just the graph. We haven't even talked about slides yet, so we have not slid anywhere. We haven't slid down anywhere. Yep. Oh, no, I think it's positive. All these numbers will all be positive because they all live in quadrant 1 and 2. Did you? Yours not showing positive? Oh no. Yeah, you typed in negative. I was at a 0.5. There you go. Fixed her up. Okay. All right, here's the first formula of the day. I already put it on the formula board. A is still your starting amount. B is still your growth factor. Nothing's changed here. But what do you think the H and K will end up doing to our graph? Slides. There's no vertex on an exponential growth, but they're slides. So the H will slide right or left. If H appears negative, it will be sliding right. And if H appears positive, it will be sliding left. It's opposite from what you expect. And then K is our slide up, down. And it's going to be exactly as it appears. So if it appears positive, it's up. If it appears negative, it's down. So yeah, so I'll just give you an equation. Let's say my equation is y equals 3 times 4, x minus 5 plus 6. See how this appears negative? It's actually a 5 to the right slide because the negative is part of the formula. Now what if it had been like this? Then it'd be 5 to the left. 6 up because it's positive, right? Yep. And that's been our theme all year, where that right-left number is opposite from what you'd expect. And if your graph slides, the asymptote slides with it. You'll see that right off the bat in the first example here. All right, so here's our example problem. Let's go ahead and put it in. So 4 is our starting amount, 2 is our growth factor. That's before any sliding has occurred. So the intercept will actually be at 4. I slid a little bit. 4 times 2. Hey, is anybody using the old TI-83 calculator in here, Spencer? You're going to need to put parentheses around this exponent of x minus 1. So you okay with that? Just wanted to warn you. To make that whole entire quantity the exponent.
Look back. I can put
We're on a new example. All right, let's go ahead when you're ready and click graph, and you'll see. Do you think, before we even go, do you think when you see that x minus 1, is that a left or a right slide? Right 1. And then what about this minus 3 right here? Down 3, yeah. So the key here is you need to realize your asymptote, which normally lives at 0, will be sliding down to y equals negative 3. That's important to know because when you have to answer domain and range questions, you have to know where your asymptote is. Click graph. There, see how it's down there? And it looks like it crossed at negative 1. Fill out our table. Negative 0.275. 2.75. Wrote that wrong.
Yeah.
Did I type it in wrong?
No, I got the same thing.
Oh, okay.
Negative 2 is negative 2.25.
Okay, so we're okay.
Can I see the equation again?
Yeah. So it's 4 times 2. You would need to do caret parentheses x minus 1, and then you'll need to end your parentheses. And then you'll need to have a minus 3 at the end.
Yeah.
And everybody's table is graphing mine? Matching mine? Let me pull it up on here. I don't know. Okay, we went ahead and graphed it, and now let's answer our last 2 questions, domain and range. Where can this graph go left and right? All real numbers for domain, because it can go everywhere at once, left and right, but can only go from -3 to infinity, up and down. I think that's what you were thinking, the up and down traveling. So okay on that?
What did you get Y for 3? As you just left it for this one.
Oh, for 3, I got 13. Because you can't actually, so if I put a bracket here, it includes -3, but an asymptote is like a place that the graph can never quite get to. So here, I'll just show you. If you would like scroll along, your numbers are going to get really, really close to it, but not actually. The number just slightly above that, and -2.999. All right, let's go to this equation here. Do you remember back in Algebra 1 when you talked about investing money at a certain interest rate for a certain amount of time? You probably used the equation P. I'm trying to think of.
I know these like.
It was A equals P times IRT or something like that. That's how you did in Algebra 1. This is super, super, super similar. It might have different variables. So A is going to be your starting amount of money. R is going to be your interest rate, but it has to be a decimal. So let's practice that for a second. What if it's a 5% interest rate? What would you put in for R? 0.05. So make sure you slide that decimal point 2 places over before you put your R in. And then T is normally your time in years. And this particular equation is for annually compounding interest. So when the bank would give you your interest 1 time per year. Do you guys have bank accounts? How often do you get your interest? Probably more often than once per year, right? Maybe once every month. I think my kids' savings account, they get the interest once per month. All right, our first example here actually isn't even a bank problem at all. A rabbit colony has 50 rabbits and it doubles every year. How many rabbits are in 5 years? So you don't actually even need the equation on the last slide because there's no interest rate, is there? But maybe just use the formula we've been using all day. A times B to the X. What's our starting amount of rabbits? What's our growth factor? It's a 2 because it's doubling every year. And 5 years are occurring. 5 years are going by.
We have 1,600.
1,600 rabbits. Well, hopefully, some of them get eaten by hawks and stuff like that.
Is there any interest rate that would be that big?
Yeah, wait till this one equation where we're looking at like a retirement fund. What? In real life, your interest rate's not going to be doubling your money every year. It's going to be more like a savings account would be like 0.001%, but maybe a good retirement fund would be 12%. So you'll see an example like that in a second. All right, here's a money problem. Tom is investing $400 at 5% compounding annually. So we can use that annual interest rate formula we wrote down. Here's what it looks like. What would go in for A? What would go in for R? And then what would go in for time? Go ahead and type that in. Yep. 651, 56. So this formula can only be used as is if you're only getting the interest once per year. And like I said, most banks give you that interest more than once per year. So I actually have another formula. It's very, very similar. It throws in one extra variable, and that's the variable N. So P is still your starting amount of money, your principal amount of money. R is still your interest rate. But now we have this new guy, N. N is the number of times per year you get interest. I'm going to give you some examples of N values in a second when you're ready.
Like a 5% compound.
5% is pretty high rate for just a normal savings account.
You said 0.01 is like
0.001. It's very low.
Then you get like $1.
I know. That's why you need to have mutual funds and stock market investments. It's an N. N times T.
N?
N times T. Alright, let's look at this example. Christy's putting $4,000 into an account that compounds quarterly. So this is the first time we've seen something like this. That word quarterly is going to give us our N value. How many times in a year do you think a quarterly would be? 4. Good. I'll go ahead and run you through some of the other scenarios. What about semi-annually? How many times do you think that would be? 2 times. Monthly? 12 times. Daily? Yep, I think that's probably all the scenarios we'll run across. So let's go ahead and put all this in our equation. 4,000 is your original investment. That goes first. Now we're doing 1 plus R over N. What's our R value? 0.065. Make sure you have converted that to a decimal. People forget to do that. Over 4. Put that 4 up here as well. I always remember when I have it here, I need it up here. And then I multiply by 20. So basically I end up getting that interest 80 times because it happens 4 times per year. I've got 14,524. So if you don't match me, let me know. We can come see why your calculator's not calculating it out right. So Spencer, you'll need a caret right here and then a parenthesis right there. Okay, that we won't do. Yeah. It's actually right here. Can you see that far? Okay. And we only have one more example problem. This is a guy who's doing a retirement fund. And he's investing that money a really long time. So retirement funds probably get anywhere from 8% to 15% if you're doing a real good year. 18%, that's a little lofty. But hey, this guy will be pretty happy at the end of the time period. Nick's investing $15,000, compounding semi-annually. That's that word we need to pay attention to. How many times per year is semi-annual? Okay, so let's get this set up. Huh. Maybe on a really good year. Do you want me to change it to 12%? 22. Okay, so we're going to go ahead and put we changed our rate because some of the students were skeptic that the retirement fund wouldn't actually get 18%, but 12% is pretty realistic. So let's put in our 15,000. We've got our interest rate. What would that look like as a decimal? And then you guys told me that semi-annually means I'm getting it twice per year. And we're doing this for 30 years. All right. Let's type this in. Did you guys get this? 494,000? No, I typed in something wrong.
No, that's what I got.
Oh, okay. Then you typed it in wrong. Let me pause my video real quick. Alright, so we're done. Here's the homework. You have, you don't have much time to start it, so just make sure you take a picture before you leave here, okay?
Homework?